Hi everybody, welcome to another Chats with Chaudhry. I hope you're safe and well. Today I'm delighted to be joined by Steve Saxe, who is the Product Line Manager at Viavi. And today we are going to be talking about NIR spectroscopy and in particular MicroNIR. And Steve, I'm very jealous because it's wet and rainy this afternoon here in Surrey. And I'm sure it's not wet and rainy where you're calling in from. So where are you calling in from?
Well, I'm calling in from lovely Northern California, Sonoma County. Santa Rosa is where our business is located. And yes, you're absolutely right. It's sunny and quite pleasant.
Well, I'm very, very jealous. So the last time you and I met was actually way back in March 2020 at the last live event before lockdown, which was
Right.
BitCon. And a lot
Eons
has
ago.
changed. It feels definitely like a lifetime ago, doesn't it? I mean, the whole of 2020 seems like a blur and that like it never actually happened. It's quite scary, really. But anyway, let's not wish our lives away. We're going to be talking about NIR, but before we do that, perhaps you give people a quick background on Viavi and also your role there.
Sure. Yeah, thanks. So Viavi, despite the name that a lot of people might not be familiar with, is our division is quite old. We started life in 1948 as Optical Coating Laboratories Incorporated, OCLI, acquired by JDSU around the year 2000, and then due to a company split, changed the name to Viavi about 4 or 5 years ago. So I spent a lot of time explaining to people who Viavi is as a result. But so our division is optical security and performance products, and all of our technologies are based on optical thin film interference filters.
Fantastic. And a little bit about your background?
My background is in physics and optics. I graduated from the University of Arizona Optical Sciences Center. And I spent a lot of my career so far at 3M Company. I spent over a quarter of a century there. And I've been with Viavi 10 years as a product line manager.
Fantastic. So let's start off with a very, very basic question. You know, I'm not being a scientist, so hopefully I can get away with this. So what is an NIR spectroscopy and what applications is it predominantly used for and what's it good for?
Yeah, very good. I happen to have a little visual supporting material here, if you'll bear with me and let me know when you can see that.
I can see it, yep. It's on the
Yeah,
screen.
very good. Okay, so this kind of basically illustrates a principle of optical spectroscopy. You take a known light source, you shine it on a material, and you analyze the spectral content of the light bouncing off the material. Every material in the universe has an optical fingerprint. It absorbs some wavelengths and reflects some wavelengths and transmits some wavelengths. And by analyzing those spectra, you can learn about the composition of the material. So in the case of near-infrared optical spectroscopy, I love this because it's got little wiggles and wobbles on it.
A little bit more interactive.
So what we're looking at here is the various vibrations of carbon-based molecules. And each of these vibrations has a unique wavelength or frequency associated with it. And over here on the right, you see kind of a table of near-infrared wavelengths from 950 to 1650 nanometers. And each of these individual molecules resonates at a different frequency. By looking at the absorption spectrum and comparing that to a mathematical model that you build of this, you can analyze materials. So it is molecular spectroscopy to be contrasted with atomic spectroscopy, which it's not. And each unique wiggle and wobble absorbs light and allows you to identify materials, determine concentrations, and analyze blends or mixtures. So whatever you can imagine doing with that tool, and it's a very, very large catalog of capabilities, that's what NIR spectroscopy is used for.
Brilliant. And what is MicroNIR then, and how does that differ then from NIR spectroscopy?
Okay. Well, this is maybe related to our heritage. I mentioned earlier that OCLI was based on optical thin film interference filters. And I'm going to start here in this little box.
Yep.
So this optical component is one that we uniquely make, and we have a very high capability in, called a linear variable filter.
Right.
And this is a narrow bandpass filter where the bandpass wavelength varies continuously from one edge to the other. In this case, for example, it has a 950 nanometer bandpass at one end and a 1650 nanometer bandpass at the other end. So it has the capability to disperse light. This technology of linear variable filter was actually developed for NASA spacecraft,
Right.
because they fly spectrometers, and an LVF-based linear variable filter-based spectrometer is very compact, lightweight, and robust. And I have the OSIRIS-REx illustrated here because it is flying a number of Viavi LVF-based spectrometers. And this is the spacecraft that just recently went into the asteroid Bennu, captured a snootful of dust and rock from the asteroid and is bringing it back to Earth in 2023. The chemical mapping of that asteroid was actually done by the spectrometer.
Right.
And so, to get to your question, the MicroNIR is a commercial instrument based on the same technology. So we take the linear variable filter, we mate it to a detector array, a linear detector array, so that each pixel in the detector array reads out a different wavelength. You back that up with some electronics and optics, and you have a very compact, lightweight, and robust spectrometer. And that is the core, the basis of the MicroNIR product line.
Right. Okay. So what, if you're looking at pharma in particular, what applications would it be used for within pharma?
Well, let's take a look at a typical pharmaceutical solid dose manufacturing process. Just from beginning to end, you begin with raw materials and some active pharmaceutical ingredient or API. They will go into a granulator and a mixing stage, which is done with moisture, then dried and blended with excipients and other lubricants and binders and other materials,
Right.
then goes into a tablet or a pellet press to make the final oral solid dose. So pharmaceutical manufacturing is very highly regulated, and for good reason. All of these processes need to be very carefully controlled and quality monitored. So when raw materials come in on the dock, it is absolutely required that the manufacturer verify that those are the raw materials that they thought they bought, right? So the opportunity here is to use a handheld near-infrared spectrometer to characterize the raw materials. So first to identify that it's the right material, and then NIR also has the ability to measure moisture content and even particle size, if you can believe that. So it's actually possible also to qualify raw materials. Continuing on in the API pipeline, these are generally liquid chemical processes for synthesis. And we are just about to introduce an immersion spectrometer for monitoring those processes. When you get to granulating and mixing, you can monitor the process of granulation step by step. They're actually, the NIR spectrum of these mixtures changes as the size of the aggregate changes. And then you can monitor the mixing as well with wired near-infrared devices. Near-infrared is very sensitive to moisture, so you can measure the degree of drying and stop the process at exactly the right point. Now, blenders are typically dynamic moving pieces of equipment. They're tumble blenders or V blenders, like are schematically illustrated here. And the ingredients, components have to be uniformly mixed, or someone will get the wrong dose. And plus, they can't be overmixed. So it's very important to begin to terminate the process at the exact right point in the blending process. And we have a wireless NIR instrument that attaches to a blender and monitors the evolution of the blend so that it can be stopped at exactly the right point.
So do you set the NIR instrument then to sort of alert you then when it's reached that particular point to say this is when it's going to stop?
Yes, this instrument is Wi-Fi connected to a computer and running Viavi software. We have algorithms that determine the endpoint of blending.
Right. Okay. So actually, it's used throughout the whole process. Is it also tablet used for the tablet and pellet pressed as well?
Right, yeah, so the wired NIR can also be attached to a tablet press to monitor the flow in the feed frame and of course, of the final product as well to assure that it's properly mixed and uniform and the right composition.
Right. So from an end user's perspective, though, I mean, I know there are a lot of different technologies out there for people to use to analyze
Mhm.
materials. So what are the sort of advantages of using NIR over other technologies, and what are the challenges that people have when they're using NIR and particularly micro NIR?
Yeah, well, NIR is first of all, it's you can use NIR spectroscopy uh, without contacting the material. You can also use it. It's non-invasive and non-destructive. So the primary chemical analysis techniques like liquid chromatography, gas chromatography are destructive. You have to take a sample, it goes to the lab, it is analyzed, and it's gone.
Right.
Also, of course, it's time consuming. What I didn't mention in the earlier slide, and maybe I'll just go back and touch on that briefly. The common routine here with raw materials is to take a sample of the material, take it to the lab while you quarantine the material coming in on the dock, right? And when the lab work is done, $300 or $400, and 2 or 3 days later, you can release this material to production. So that takes floor space and time that are costly to manufacturers. And the same thing is true in many of these other steps, that the primary technique is to steal a sample and take it to the lab. Everything goes on hold while that happens. So NIR spectrometers can monitor these processes in real time and assure quality. This is a method called quality by design,
Yeah.
or it's a lean manufacturing approach, and is really a very strong trend in pharmaceutical manufacturing toward process analytical technology, or PAT, and bringing the measurement of the process directly to the process.
Right. Okay. And in terms of what are the sort of common challenges that people might face, and how would they overcome them if they're using NIR?
Yeah. So NIR is while it has those wonderful advantages of being non-invasive and non-destructive, and it's also very fast. You can get an analysis result using our software in 5 seconds, which is to be contrasted with many hours in the laboratory. It does take a certain amount of preparation and even technical expertise, I would say, because what one does is one builds a chemometric model.
Right.
By taking a bunch of samples and measuring them and creating this mathematical model, which is then used to predict an actual measurement. So it takes a certain amount of expertise and patience for a user to build the chemometric model, to test it, to validate it, and to make sure that it stays current and accurate. So that's probably the biggest challenge. The pharmaceutical industry is very familiar with chemometrics and modeling, and in general ready to adopt. But there are tremendous applications in feed and food and agriculture, where the manufacturers are less familiar with NIR. So one of our challenges as an instrument maker is to educate the various market segments on the capability and to kind of help them over the hump of building useful chemometric models.
Now, you mentioned when you're doing your little presentation about the software as well. So what does the software do in terms of supporting instrumentation? Because I know when you look at when you talk to a lot of instrument companies, they talk about software, they talk about databases and how they can obviously have already within their methods and also data that people can measure against to make the end user's life easier. So from your
Yeah.
point of view in NR, is it very similar in terms of the NIR world and the software that you're producing, that is all about making life easier for the end user?
Yes, and so what differentiates our software from others is we provide a toolkit. The MicroNIR Pro software suite is basically a complete chemometric modeling suite that users can use to build their own chemometric models. We can build chemometric models for customers, but we have very limited capacity to do that. So we provide a very easy to use, kind of self-explanatory toolbox for a customer to make their own applications. Many other companies offer turnkey solutions. They have the chemometric models built, and they provide the models, say, on a subscription basis, etc., which is, I think, something that users definitely want, and find a great convenience and accelerator for their adoption. But it can run into considerable expense over the long haul if it's, for example, subscription-based, or you need to renew the model regularly. So this is one of a total cost of ownership gives us an advantage, but it does put the obligation on the user to build the chemometric model.
Right. Okay. And looking ahead, where do you see the future for NIR and MicroNIR in terms of its usage? I mean, obviously you showed it's pretty much used through the whole supply chain there in terms of pharma, but in
Right.
terms of applications, where do you see the future for NIR and how the technology develops going forward?
Yeah. Well, pharmaceutical manufacturers are not the only ones who have the basic quality management issues, right? They happen to be in a regulated environment where they have the stakes are higher for sure. But manufacturers of food products, right? Cake mixes and Tootsie Rolls. Shouldn't have said a brand. Anyway, all kinds of food products are blended and mixed, and synthesized. And so there's a tremendous opportunity to move NIR spectroscopy into those industries. And we have several lead customers who are working in that area. We have a longstanding lead customer in agriculture where they use the MicroNIR, specifically the on-site W, which is our portable handheld instrument, to measure feed for cattle and swine and poultry, and they measure the forage or the silage for nutritional content, and that guides the rancher farmer on what kind of nutritional supplements the animals need in order to be maximally productive of eggs or milk or whatever. So big opportunity in that direction as well. So I think the big application opportunities are in food, feed, and agriculture.
Fantastic. Well, if people want to know more information, Steve, where can they get more information about NIR and MicroNIR?
Well, we happen to have a website. I'm sure you're not surprised to hear that. What I'm going to do is I'm just going to share. Where are we? MicroNIR.com is our website, and you can find contact information there. You can find information about our lead customers who have turnkey applications, what we call our cloud mobile solutions partners. What I didn't mention earlier is that our handheld instrument is Bluetooth connected and can be mated to a smartphone to make a very elegant portable field solution, and several of our customers are doing that. So you can learn about what they offer at our website. You can learn about our several products, and you can find where to buy information. We have a worldwide network of a couple of dozen distributors throughout the world, so resellers of MicroNIR products, and they can provide you a lot of information as well.
Brilliant. Well, thank you very much for that, Steve. So I hope you found that useful. I've learned a lot more about NIR and MicroNIR than I started this conversation with. Hopefully you did too. And actually, this was the first. We actually did a little semi-presentation as we were going along. So I hope you found that interesting. If you'd like to know more information about NIR and MicroNIR, and obviously the solutions Steve was talking about from Viavi, then please check out the website address. It was on that slide, so you can see it on the video, but also I'll put the link above the video itself, so you can click on that. Apart from that, I'm sure there's lots of white papers and other technical information there if you want to know more. And if you've got any questions for Steve, then please leave them below the video, or you can send them to him directly on LinkedIn. Steve is on LinkedIn as well. So, Steve, all that's done when he says jealously and through gritted teeth, I say enjoy the rest of your day in sunny California, and also the rest of the week. It's lovely to see you. And also, we won't go into it, but Steve just mentioned it was his birthday only very recently. Was it yesterday? Happy birthday for yesterday. You're looking fantastic. I won't say how old he is, but he's looking good. That's all I can say. So it's lovely to see you, my friend, and hopefully we can catch up face to face at some point as well. So thank you very much for your time.
I hope so too. Thank you, Rizwan.
And thank you for watching. Genuinely, I hope you found that useful as well. If you've got any questions, please get in touch with Steve, or leave some comments below, or check out the website. And until next time, as always, I hope the sun is shining where you are, because it hasn't been where I am today. So until next time, stay well and stay safe. Bye-bye.